Hi, so in this video, we're going to be working with proving angles congruent. So we are going to use the theorems, postulate, and all the definitions that we already know and properties to prove that angles are congruent or the measure of angles. So this one is telling to complete a complete paragraph proof below, right? So it says that angle 1 and angle 2 are complementary angles, and angle 2 and 3 are complementary angles. And it says that BD bisects angle ABC, right? So let's use that information to prove that the measure of angle 1 equals 45. So we know that angle 1, and angle 2 are complementary angles, and that 2 and 3 are complementary angles because these facts are given by the definition of complementary angles. We know that then angle 2 plus angle 3 equals 90. Right? Now, given that PD bisect angle ABC, it follows that, right? If this is the bisector, that means that this angle is congruent to that one. So it's splitting the angle in half. So that means that the measure of angle 2, so the measure of angle 2, equals the measure of angle 3, right? So using the substitution right here, I have that angle 3 plus the measure of angle 3 equals 90, right? Because then I can substitute for angle 2 on this equation right there. I can substitute angle 2 for angle 3, right? So, or that 2 times the measure of angle 3 equals 90. I can do exactly the same with angle, 2, right? Now, using the division property, so division property of equality, I know that the measure of angle 3 equals 45, right? By the congruence complement theorem, I know that angle 1 is congruent to angle 3, right? Because why do I know that? Because the congruent complement theorem says that if I have an angle, I have two angles that are complementary to the same angle. So 1 is complementary to 2, 3 is complementary to 2. So that means that 1 and 3 must be congruent angles, right? So now, because those two angles are congruent, I know also that the measure of angle 1 equals the measure of angle 3, because congruent angles have the same measure. And by substitution, I know that the angle 1 equals 45 degrees, right? So I'm substituting this on this equation right there. So I'm substituting angle 1 for angle 3. And I have proven this exercise. Now, this one I want to prove. I'm given that angle 1 is congruent to angle 2. Let's mark that information right here because it's going to be easier later on. Angle 1 is congruent to angle 2, right? And we're going to start with that information. So angle 1 is congruent to angle 2. And the reason for that is that information is given. Now, I want to prove, I'm going to mark that, let's say in another color blue. I want to prove that 3 and 4 are congruent. I don't know that they're congruent. I want to prove that. So from angle 1, angle 2 is given, right? Now, what other information I will need? I know that this whole angle, right, if I add the measure of angle 1 plus the measure of angle 3 plus the measure of angle 5, that equals to 180. Right? And I know that because I'm adding angles, so the angle addition postulate. Now I'm also given that the measure of angle 5 equals 90 degrees. So this is also a given, right? As you can see right there, they're writing that square right there. That means that is a right angle. So with that information, I can substitute that on the next one. So the measure of angle 1 plus the measure of angle 3 plus 90 equals 180, right? That's substitution. Okay. Now, from that information, I have that the measure of angle 1 plus the measure of angle 3 equals 90. 6, 5. This is by subtraction. Property. Let me erase this information right here so we can continue working with the exercise so you can see it, right? Now, this angle is congruent to this one up here, down here, because they are vertical angles. So let's write it with the information. So the measure of angle 5 equals the measure of angle 4 plus the measure of angle 2. Why? Because vertical angles are congruent. So now number 7. By substitution, I know that these two are complementary angles. So 7 is by substitution. Right? Now, but I know that angle 1 is congruent to angle 2. So that means that I can also substitute on this equation angle 4 plus the measure of angle 1. So again, this is substitution also. So I can substitute that there, right? I can substitute that there because I know that angle 1 is congruent to angle 2. So that means that I can substitute angle 2 for angle 1. Now, so now at the end, I know that angle 4 equals the measure of angle 3. Right? This is because of the congruent complementary theorem. Let's go over that again. So if angle 1 is complementary to angle 3, right? Because they are complementary angles. So we have it here. We prove it already that they add to 90. And 4 and 1. So 4 and 1 are also complementary angles. So 4 is complementary to angle 1. Angle 3 is complementary to angle 1. So that means that 3 and 4 must be congruent. So in this one, I know that the measure of angle BOEF is this angle right there. Let's mark it in another color. So this one is equal to that one. So that means that those two angles are congruent. And I want to prove that AOE is double the measure of BOF. Right, so let's start with the given. So again, my first tab. So 1, the measure of angle BOF equals the measure of angle FOD. So 2, that's, or 1, that's given. Number 2. So if I add the measure of angle BOF plus the measure of angle FOD equals, so this one plus that one equals the whole angle. So the measure of angle BOD by angle addition postulate. So now on 3, that means that I can, and I'm going to use BOF because down here I need to prove the BOF, right? So I can substitute. So the angle BOF plus the measure of BOF equals the measure of angle BOD by substitution. Again, I'm substituting. I know that the measure of angle BOF equals FOD. So that means that on this next equation, I can substitute. I can replace one with the other one, right? So if I combine like terms, I know that the S2 times BOF equals the measure of angle BOD. So here, combining like terms. So number 5, I know that angle AOE is congruent to angle BOD. Why? Because vertical angles are congruent. Vertical angles are congruent. So by definition of congruence, I know that the measure of angle AOE equals the measure of angle POD. So definition of congruence. And number 7, again, I already know that BOD is the same as 2 times BOF. So the measure of 2 times measure of BOF equals the measure of angle AOE, 7. So this is by substitution property. Okay, my last statement should never be a given. I need to prove that, right? And it's never going to be a proof, right? We don't write proof there. We just write the reason why we're going from 6 to 7. That's it for the lesson. May the force be with you.